research proposal is mathematical model on climate change. So first of all, my introduction that climate change refers to long-term shift in temperature. Due to lack of time, my research proposal. In this research, we create mathematical model on climate change. वो ऐसे इंडिकेट करते रहेंगे देखो So continue. In this research, we create mathematical model on climate change. We may define the climate as the collection of all long-term statistical properties of state of the atmosphere. We may represent the instantaneous state of the atmosphere by the three-dimensional field of temperature, pressure, density, wind velocity, and water in its gaseous, liquid, and solid space. The variation of these fields as time progresses are brought by general physical law. We may express these as mathematical equations which specify the time derivative of each atmospheric variable as a function of the state of the atmosphere and its environment. If we are to solve these equations, we must know how the environment will behave. Frequency, we simplify the problem by assuming that the state of environment is known. The research objective, my research objective, define and differentiate climate change, global warming, and greenhouse effect. Second is understanding the relation between causes and effect of climate change. That is understanding sensitivity and time scales and the reason for extreme events. Fourth, recognize the impact of climate change in the society. Fifth, present solutions and ways on how to mitigate the effect of climate change. To make recommendations for local public health, government, and environment organize on health and take action at a local level. My research parameter or data is air pressure, air velocity, air ocean temperature, air density, cloud, solar radiation, earth rotation, gravity, mountain. My research methodology, all climate models start with the law of physics, are formulated as differential equation. Incorporate data, quantity, uncertainty are solved numerically. Example of the simpler models, energy balance model, and these are the total incoming solar radiation, atmosphere, earth, energy flux from earth, energy flux from atmosphere, energy received by earth as short wave radiation, long radiation from the earth as long radiation, plus balance 1, that is the equation, plus balance equation 2, that's the equation. This is the power of this model is its ability to make prediction of the sensitivity of the earth to change in CO2, carbon dioxide. However, Avogadro is directly linked to the temperature. This significantly increases the sensitivity of the temperature to change in carbon dioxide. This is the dT by dt, that is the frequency change. This is the graph for typical points. That the conclusion is the mathematical models are the best way to predict future climate and understand past climate. A hierarchy of models is needed to make useful prediction over the full range of time and length scale. Models are only as good as the physics and data underlying them. But do this correction and you should get the right answer. Thank you, sir. Yes, sir. Yes, sir.
You just read what you want to describe.
Sir, just
What you want to describe in this brief, that's not in your own note. I don't want any this kind of proposal, whatever you have written.
Yes.
That is that note. Just tell in your own word what you want to express.
Actually, sir, this is the mathematical model based on the climate change.
Which type of model you have considered?
Sir, this is the mathematical model. We create the equation. There we can.
And you have told about this differential equation and partial differential equation you have
Yes.
applied over here.
Yes.
And which are the parameters you have considered?
So parameters are temperature and density and clouds and different.
So any boundary value conditions are there?
Yes.
So what boundary value conditions you have considered?
So boundary.
Without boundary value condition, you supposed to it is quite impossible to describe our result changes. No, it is continuous process.
Yes, sir.
And this continuous process can be obtained through the parametric changes, and that parametric changes can be described with respect to some parameters and their boundary conditions.
Yes.
So which type of boundary conditions you have considered?
So basically, sir, I have to all the variables like we get the climate.
Simply just tell. I don't want to just you just tell, because I'm a layman. I just want to know what about your proposal and why this proposal is necessary today for the climate changes and describe you have described in a mathematical way. So is it very necessary for our society or not? Because every research have the some kind of necessity for the society. That's why the research is necessary. Otherwise, isn't it? So you just describe in your own word. Maybe you can tell in Hindi, no problem.
Yes, sir.
So what you want to express actually?
Sir, actually, I do sir the mathematical equation.
Just tell in Hindi, sir. It is quite easy. I think.
सर मैं चाहता हूँ सर कि एक मैथमेटिकल एक्सप्रेशन के थ्रू क्लाइमेट के थ्रू जो आपके इन्वायरमेंटल में चेंजेस आ रहा है उसमें जो वेरिएबल पैरामीटर्स है लाइक दैट वो किस तरह से इफेक्ट होता है जिसके कारण क्लाइमेट में चेंजेस आता है लाइक वो मैं ये सब बोलता हूँ.
So you have just you go for your third slide, where you have just considered the base equation. Yes. And the atmospheric T of A, TA is,
Yes,
TO is 242 K. Is it constant for everything?
yes sir, ये टोटल पूरा रेडिएशन है.
And Earth for it is 288 K.
Yes sir, this is अर्थ
And flux is also considered. And you have not given the changeable values of this sigma and T.
Yes sir, this one I have to read sir all the lecture.
That means it is under process.
Yes sir, that was.
Okay, thank you.
Thank you very much.
Next, Anjana Ekta. Now, Shashika is available, na? Okay, you ready? After her,
Good afternoon, everyone. My name is Anjana Ekta. I'm a research scholar from the Department of Mathematics, and the supervisor is Dr. Pinky Pandey. Today, I'm here to discuss on the topic construction of group divisible design by triangular design. So I'll start some basic definitions first. So first, we will know that what is association scheme. So a relationship defined on B treatments is called an M-class association scheme. Each pair of treatments are either first associates, second associates, or n associates, and the number of ith associates of a treatment is constant, that is denoted by ni. And if two numbers two treatments are ith associates of each other. Then the number of treatments that are jth associate to first treatment and kth associate to second treatment is a constant that is denoted by Pijk, and this number is independent of the pair of treatments which are ith associates, and the parameters to association schemes are BMI and Pijk, that's constant. Association schemes can be represented by graphs. 0, 1 matrices, that means matrices with entries 0 and 1, and relation matrix. Here I have taken a triangular association scheme with 10 treatments. Relation matrix is represented, association scheme of relation matrix is represented here. First associates of element 1 is 2, 3, 4, 5, 6 and 7. In red color, and second associates are in green color. Similarly for other treatments, I have mirrored here. And next definition: partially balanced incomplete block design. A partially balanced incomplete block design is an arrangement of B treatments in B blocks of size K based on an association scheme such that each block contains exactly K distinct treatments where K must be less than K, and each treatment occurs R times in the design, and two treatments that are mutually ith associates occur together in exactly lambda blocks, and these are the parameters of partially balanced incomplete block design. Next, group divisible design. Let B is equal to M multiplied n treatments be arranged in an M cross N array. Then a group divisible design is an arrangement of B treatments into B blocks such that each block contains K distinct treatments, each treatment occurs R times in B blocks, and every pair of treatments which are in the same row of the M cross M array occur together in exactly lambda 1 blocks, while other pair of elements occur together in lambda 2 blocks, and B is equal to M multiplied M, B, R, K, lambda 1, lambda 2 are known as parameters of group divisible design, and that parameters are satisfied the relations B multiplied K is equal to BR, and N minus 1 multiplied lambda 1 plus N multiplied N minus 1, lambda 2 is equal to R multiplied K minus 1. And next definition is triangular design. So a triangular design is an arrangement of B treatments into an N cross N array such that positions on the principal diagonal are left blank, and the positions above and below the principal diagonal are filled up by the treatments in such a way that the resultant arrangement is symmetric about the principal diagonal, and these are the parameters of triangular design. Next, construction of group divisible design. My paper is based on this theorem only. So construction of group divisible design by triangular design. So statement: the existence of triangular design based on triangular association schemes with parameters. These parameters leads to the existence of group divisible design based on group divisible association schemes with parameters B is equal to N multiplied N, R B is equal to N, R is equal to 1, K is equal to N minus 1 by 2, lambda 1 is equal to 1, and lambda 2 is equal to 0. So proof of this theorem is first we have to consider the triangular association scheme with B treatments, and if we take each row or column of this triangular association schemes as block, then we get a triangular design with these parameters. Now we arrange these B treatments into an N cross M rectangular array to construct group divisible design. Then we consider each row of this M cross M rectangular array as a block. We get a group divisible design with parameters A is equal to N multiplied N, B is equal to N, R is equal to 1, P is equal to N minus 1 by 2, lambda 1 is equal to 1, and lambda 2 is equal to 0. We satisfy the relation BR is equal to BT, and lambda 1 N1 plus lambda 2 N2 is equal to R multiplied K minus 1, where N1 is equal to M minus 1 and N2 is equal to M multiplied N minus 1, which I have earlier discussed in definition of group divisible design. So we have M is equal to Mn, Nm, and B is equal to N, R is equal to 1, K is equal to N minus 1 by 2. Then it follows that BR is equal to BK. Now these are the parameters of group divisible design. Now we are verifying it. It follows that VR is equal to BK. And since N1 is equal to M minus 1, N2 is equal to M multiplied M minus 1, and lambda 1 is equal to 1, lambda 2 is equal to 0, it follows that lambda 1 N1 plus lambda 2 N2 is equal to R3 minus 1. Since both the conditions are satisfied, therefore, group divisible design can be constructed by triangular design using association scheme. Also, this design is like the singular group divisible design as R is equal to lambda 1. I have taken an example to illustrate this theorem. So let n is equal to 5. The triangular association scheme for B is equal to 10 treatments is written here. And the blocks are formed by writing all the treatments lying in the same row or column as in first block 1, 2, 3, 4. That means first elements of first row, and second block elements of second row, third block elements of third row. Similarly for fourth and fifth. And the above design is triangular design with parameters written here. Now arrange the same B is equal to n treatments into an m cross 2 rectangular array of 5 rows and 2 columns. Then in first row 1, that means first block is 1, 2, second block 3, 4, third block 5, 6, and fourth block 2 elements are there 7 and 8, and in fifth block 2 elements are there 9 and 10. Here rows represent number of blocks of the design and columns represent block size. So here we have 5 blocks with 5 blocks and number of elements are 2. The above constructed design is group divisible design with parameters. B is equal to 10, B is equal to 5, that is number of blocks is equal to 5, R is equal to 1, that is replication of each treatment is 1, K is equal to 2 means block size is equal to 2, lambda 1 is equal to 1, that means if we take a pair of treatment then it will occur in only one block, and lambda 2 is equal to 0. And for which we hold that VR is equal to BK. B is equal to 10 and R is equal to 1. So VR is equal to BK. And lambda 1 M1 plus lambda 2 M2 is equal to R multiplied A minus 1. Also, this group divisible design is singular as R is equal to 1 and lambda 1 is equal to 1. So conclusion, if we have triangular design with these parameters, then we can construct group divisible design with parameters are written here. These are references. Thank you. That's all.
Sir, any questions? Upside. Upside. Over there.
Go for first introduction.
Introduction.
So, each pair of these treatments are either first, second, and Mn up to Mn plus 6. And number of isotopes are treatment out. So, madam, actually, what is the necessity behind this research?
So I will not get it.
What is the necessity behind this research? इस रिसर्च के पीछे इसका ऑब्जेक्टिव क्या है? वही है कि
There are so many applications of group divisible design, like in daily communication, in cryptography, and in experimental design.
So can you example each one? Can you example each one?
Applications.
Example of
applications.
yes please.
Shall I explain in Hindi?
Yes, no problem.
Sir, actually जैसे association scheme है, तो 0-1 मैट्रिक्स हम ये रिप्रेजेंट कर सकते हैं. और जैसे मैं छोटा सा एग्जांपल लेती हूँ, जैसे गूगल में हम कुछ टाइप करते हैं, कभी-कभी स्पेलिंग मिस्टेक होने से भी वो करेक्ट रिव्यू मीन दिस करके आता है, 2-3 सेंटेंस उससे मिलता हुआ, तो वहाँ पे इसका यूज होता है, क्योंकि यहाँ पे ग्रुप डिविजिबल डिजाइन में 0 and 1 यूज किया जाता है. 1 मीन्स अगर फर्स्ट एसोसिएट या सेकंड है और नहीं है उसके लिए जीरो करते हैं। तो अगर कोई वर्ड हमने टाइप करा और अगर वो रॉन्ग है तो उस केस में या फिर उसको करेक्ट करने में
तो ये करेक्टिव मेजर आपके हिसाब से कितने अप्रोक्सीमेशन तक चलेगा? मतलब अगर continuously if I were going to write the different number of keys, Google cannot rectify it. So Google will rectify only when we are giving some kinds of words, meaningful words, and some parameters are absent or wrongly typed, that can estimate approximated by Google.
So it's spelling wrong होगा तब
Then on. So if I am going to 100 letters in a wrong way, can Google rectify it?
I can't say sir.
So are you going towards this research or not?
I'll think about it. I'll work.
You are going to research to that one. That is how many wrong mistakes are there, and I can rectify or my approximation can rectify this one. So that's why that is my question, that how much rectification is considered by your research?
Sir, I'll work on it. I don't know.
Okay, ma'am. Thank you.
Thank you sir for the suggestion.
Okay, thank you.
Respected Principal Sir, HOD Ma'am, Ranchi University, Mathematics Department, all faculty members and students. My name is Sasikant Agarwal, Research Scholar of University Department of Mathematics, Ranchi University, Ranchi. Now, my research paper is based on predicting a random determinant with IID independent and identically negative binomial variates. This is based on different topics in mathematics like probability, statistics, combinations. We know that in plus 2 level, Bernoulli's trials. Let there be n number of trials and p be the probability of success and q be the probability of failure. Then by Bernoulli's trials, we find that probability of getting R success is NCR p to the power R q to the power n minus R. This suggests me that if we apply another probability distribution, negative binomial variates, then what is the prediction of a random determinant? So, my abstract is, this paper gives a probabilistic analysis of a determinant of order 2 and 3 in which elements are IID negative binomial variates. Using Jepson's inequality, Punnician limits of D are obtained for order 2 and 3. These results may be compared with those obtained for other standard probability distribution. I will also work for higher order, for 4 order, and we generalize for n order also, but this paper is based on only for order 2 and order 3. Now, what is negative binomial distribution? Let F denotes the probability that there are X failures preceding the R success in X plus R trials. That is, total number of trials is X plus R. Now, the last trials must be a success. Then what is the probability? Let B. Then in the remaining X plus R minus 1 trials, we must have R minus 1 successes. Probability is given by binomial probability law by expression this. Now, after compound probability theorem, we get the mathematical expression for negative binomial distribution is f is equal to x plus r minus 1 c r minus 1 p to the power r q to the power x, and the probability mass function is given by which shown in the given PPT. Now, what is the application? Negative binomial distribution finds application in reliability and survival analysis. How? Some of the commonest examples of such behavior are frequency distribution of plant density obtained by quadrant sampling, and when the cluster of plants makes the simple Poisson model inapplicable, because it has shown by the different investigators that in such cases the negative binomial distribution provides an excellent model because the distribution has a variance larger than the mean. The most important point is in this negative binomial distribution variance is greater than mean. Now, this is the another application for modelizing bacterial clustering, death of insects, number of insects bites leads to the negative binomial distribution. Now, what is Cmaes inequality? States that for a random variable, probability of expectation of x minus k standard deviation of x, that x less expectation of x plus k into standard deviation of x is always greater than 1 minus 1 by k square. Now, this is Cmaes inequality. The proof of this inequality is shown in Gupta and Kapoor 2014 edition and also Solari 2018. Now, what is the previous one? In 1991, Weiss and Halls see that distribution of a determinant of order 2 for IID variance. Now, this is extended by Saha and Chakrabarti 2019 for some distribution. Now, after that, Chakrabarti sir say that this results can also be proved for negative binomial distribution. Now, I work for it and I first take random determinant of order 2, and in this case negative binomial distribution is RQ by P, where Q is probability of failure and P is the probability of success. Now, and the variance of negative binomial distribution Px is RQ by P square. This proof is also in Gupta and Kapoor. Now, expectation of D, when we find expectation of D for a random determinant of order 2, this gives a result that this is 0 for a random determinant of order 2. Now, for finding variance, we use the formula of standard formula Vx equal to E of x square minus Ex whole square. Now, after calculating it, we get a result of E to the power x square is equal to RQ 1 plus RQ by P square. I give this as result number 3, and I find for the variance of T. Now, after calculation, we get a result for variance is equal to 2r square q square 1 plus 2rq by p to the power 4, and we know that standard deviation is under root variance. Therefore, we take square root of variance, which gives, generally for the standard deviation we use the symbol sigma. Then the result is root 2 rq 1 plus 2 rq whole to the power 1 by 2 by p square. Now, what is the result? And then Cmaes inequality, this gives p of minus k sigma less than t less than k sigma greater than 1 minus 1 by k square, where sigma is root 2 rq into 1 plus 2 rq whole to the power 1 by 2 by p square. Similarly, I did for the order of determinant of order 3. Now, determinant of order 3, first I break determinant of order 3 where A, B, C all are IID negative binomial variables. Now, after calculation, we get also expectation of D is equal to 0 and variance when calculated, it gives a result of this, and finally we get a standard result after calculation. Variance of D is equal to 6 RQ Q 1 plus 3 RQ by P to the power 6. Now, I find standard deviation for determinant of order 3 and putting the values in Cmaes inequality, this gives a standard result. Now, final conclusion is this is the order 2, result for order 2, and this is the result for determinant of order 3, where expectation of D is equal to 0 and sigma is the standard deviation and variance of D is equal to this. These are the ethical statement and these are the references. Thank you. Any questions?
Sir, can you go for the at first where you have considered x plus r minus 1, that is x here to the power a to the power n minus r, that equation we have taken. Yes. So, what actually r minus 1 denote?
R minus 1
Denote.
R minus 1 denotes the number of observations after getting a success. If 5 times success, then R is equal to 5, then 4 times failure. So R minus 1 denotes the number of failures.
That means r times success you are telling, not r times trials.
Yes, sir.
R times trials?
No,
or
sir.
R times success?
Total number of trials is X plus R. Total number of trials is X plus R, where X plus R minus 1 must have R minus 1 successes. X successes are the number of failure. R minus 1 times success.
So you have put it over this q to the power x.
Yes,
So
sir.
is that success or failure?
This is the expression probability mass function.
So that the
Yes, sir.
in case of probability function, what we actually in binomial distribution, that is LCR q to the power r, q to the power n minus r.
Yes, sir.
So n minus r actually denotes the number of failures.
Yes, sir.
So you have considered number of failures, that is x plus r minus 1.
Good, sir.
So
Total number of trials is X plus R. X is the number of failure.
X is
R
the number.
minus 1 is the number of success. And after that, we get a success. Then what is the probability mass function for getting Rx success after we get X failures and R minus 1 successes? Then we get Rx success.
now we go for this Cmaes inequality.
Okay, sir. Yes.
Yes. And the expectation minus you have just given
A.
A is A,
Yes.
which is less than x, less than of this. So what actually this capital X assumes?
Capital X is here. Capital X is assumed for random variable.
Now my question is,
Yes.
these random variables are your total trials or your total success?
No, sir. Here I take random variable random determinant.
Yes.
Then we take first random determinant of order 2 and random determinant of order 3. But the elements of that determinant are from IID values.
Determinants from IID values.
Yes.
Okay, fine. Fine. Expectation and we give the standardization. Okay, fine. Now you just go conclusion. I just want to know what is the actual work.
Yes.
That's it. Now, yes. If these are order 2 in the IID negative binomial variance input, then we are having the standard deviation and E of B equals to 0. Oh,
Yes.
okay, and variance you have got that. Okay, fine. Okay, thank you.
Thank you so much.
Thank you. Nice.
Now another 3 papers are remaining for this session, which are going to be delivered by online. This session क्या नाम बताइए? तो ऑनलाइन के बाद ऑनलाइन वेट कर रहा And this meantime, I would like to request Honorable Director Sir Dr. Vishnu Chattopadhyay to felicitate Dr. Asalata Kiski Madam. Please, ma'am. Performance is available here?
Yes, sir.
Yes, sir. You please unmute and continue your presentation, sir. And you please share your presentation first.
Hello.
Yes, sir.
Am I audible? present?
Yes, you can.
Okay. Good evening, everyone. Myself, Dr. Mahto, Assistant Professor, Department of Mathematics, St. James College. Title of the presentation: Analysis of a mathematical model with variable population size. These are the outlines: introduction, formation of the model, assumption, model equations, stability analysis, conclusion, and references. Now, in epidemic model, the assumption for the total population to remain constant. If the disease spread, if the disease is modeling over many years, the births are approximately balanced by the natural deaths. But if the disease-related deaths or the birth are not balanced by the deaths, then the population size must vary. The model considered here is an SIS type model because it susceptible leaves the compartment to become infectious and then again becomes susceptible after recovery from the infection. The more common assumption that the recovery rate is proportional to the number of infected leads to an ordinary differential equation of the infected fraction. In variable population size models, the epidemiological and demographic processes interact with the new behaviors which do not occur in models with constant population size. When the disease persists, the disease-related deaths and the reduced reproduction of infected can reduce the growth rate or change a growing population into a population with a stable size or a decreased size.
Babu sir, you please share your presentation.
I am sharing my presentation.
No, it is not visible.
Is it visible or not?
No, it is not visible.
Oh. Someone else presenting, sir. That's why.
Is Jitendra is presenting for you?
No. Someone is presenting, so my presentation is not visible there. I am presenting.
Yeah. Now it is visible. Continue.
Okay. In variable population size model, the epidemiological and demographic processes interact with the new behaviors which do not occur in models with constant population size. When the disease persists, the disease-related deaths and the reproduction of infected can reduce the growth rate or change a growing population into a population with a stable size or a decreasing size. The disease persists or remains endemic if the infected fraction of the population is bounded away from zero in a population approaching extinction so that the number of infected goes to zero. The disease can still persist if the infected fraction is bounded away from zero. Now, in a population growing towards infinite size, the number of infected could be bounded away from zero, but the disease would be persist if the number of infected remains constant or grew at a slower rate than the population size. Various models in which disease-related deaths and disease-reduced production can affect the population size were formulated in the 1981 by Anderson and me, and Greenhall studied SIS, SCIS, SIR, and SCIR models. In this paper, we assume that the vaccinated individual lose immunity than an individual remains in the vaccinated class and T before returning to the susceptible class. Now, formation of the model. A population size N is divided into the compartments S to denote the number of susceptible, I denotes the number of infectious, and T denotes the number of individuals
who are immune from the infection at time t. So the total population with vaccination is n equals S plus I plus T. Now the assumptions are the new competent individual enter into the population for the new time is B, and the fraction small b is vaccinated. So b lies between 0 and 1. The natural death rate in each class is d, where d is constant and greater than 0. A greater than 0 is a fraction of the susceptible which is vaccinated. All the newborns are assumed to be susceptible, and each infection makes beta into n contact per unit time. Gamma greater equal to 0 with the constant rate of infection recovered, and alpha greater equal to 0 with the rate of infection dies from the disease per unit time. And for any time t greater equal to 0, AT is assumed to be the probability that a vaccinated individual are immune at time t before returning to the susceptible compartment, such as A0 plus equals 1 and integral 0 to infinity du du equals omega. The mean length of immunity, which is assumed to be positive and finite, with a general A with a state function corresponding to a constant period of infection. Since S by n is the fraction of susceptible, then the rate of new infective at time t is beta into n into S by n into I is equal to beta Si, where beta greater than 0 is the rate of contact. This is the model equation, where T naught T is the number of individuals vaccinated with immunity at T equal to 0 and still have immunity at time T equals 0. And T naught T is a non-negative, non-increasing piecewise continuous function. Since A is a step function with AT equal to 0 on 0 to omega, and 0 is omega to infinity, where omega greater than 0 is the constant length of having immunity. So AT is initially vaccinated individual return to the ST compartment in time omega. So T naught T equal to 0 for T greater equal to omega. And the integral equation becomes equation 4, which is written here. So we discussed the SIS model obtained in equation 1, 2 and 5 as follows. Now since T is not present in first equation of equation 6, so we discuss only the first two equations of equation 6. That means ds by dt and di by dt. And the initial condition for equation 8 is st equals ft greater equal to 0, it equal to gt which is also greater equal to 0 in time t which lies between minus omega to 0, and f0 greater than 0 and g0 greater equal to 0. And here we assume that the t small t lies between 0 and 1 and the other parameter is positive. Now theorem 1 is if I0 equal to 0 and Ig equal to 0 equivalent to 0 for t greater equal to 0 and limit t tends to infinity st equals s2. Second is if I0 greater than 0 and Ig greater than 0 for t then d equals si where as f and I both are greater equal to 0 is positive, and s plus I less than capital B by D is a positive invariant set of equation A. And also, if beta into x naught greater than gamma and s2 less equal to s naught, then the solution is equals st of equation A with initial condition 9 satisfied. St lies between 0 to s naught for t greater than 0. And here, proof of this theorem is. For first stage, from equation 2 of equation 8, in second equation of equation 8, we have R0 equivalent to 0 and t greater equal to 0. And if I0 equal to 0, then from equation 8, we get ds by dt, and let's define k1 which is equal to half of s minus s naught square plus t plus a by 2 integral t minus omega to t s theta plus s naught whole square d theta, where dk1 by dt is negative k1 and limit s tends to limit t tends to infinity, st equal to n plus 0. This is theorem 2 for R1 equal to beta x naught by d plus alpha plus gamma. And for disease free to the T1 s not d. For equation 3 or we can use and if R1 greater than 1, then equation 3 also has a unique ending where xt equals d plus alpha plus gamma by d and I2 is given here. So T1 is stable for R1 less than 1 and unstable for R1 greater than 1. That means T2 is stable for R1 greater than 1. Here R1 means the basic reproduction. Proof of this is by calculating T1 is the only equilibrium of equation A is for R1 less equal to 1 and P2 is also the only equilibrium of equation A for R1 greater than 1. For the stability of the equilibrium T, where S star equals S naught and I star equals 0 for T1 and S star equals S2 and I star equals I2 for T2. So we define Pt equals S2 minus S star and Qt equals It minus I star. So from equation 11, the characteristic equation of A at T1 and Pt bar given by equation 12 and equation 2. And there if P1 is stable when R1 greater than 1, that is beta is not greater than d plus alpha plus 1. And equation 12 has a root lambda equals beta s minus d plus alpha plus gamma which is greater than 0. So P1 is unstable. And all the roots of equation 13 have negative real part. Therefore P2 is asymptotically stable. And the conclusion is, if we obtain the threshold R1, where R1 represents the basic reproduction number, the basic reproduction number is the average number of secondary infections produced when one infective individual is introduced into a host population, where everyone is susceptible. It is equal to the multiplication of the infective contact rate theta, and the average period of infection is 1 by d plus alpha plus gamma. And the number of susceptible when population remains the steady state without disease. When R1 less than 1, then the number of I, that means infective population of the infected individual, decreases monotonically as T increases, and the disease dies out ultimately. And when R1 less equal to 1, then the disease also dies out ultimately. And if Xt not like d plus alpha plus gamma by beta and d by d, then I increases initially and after a certain period of time, it begins decreasing monotonically and gradually tends to 0. That is, the disease will be epidemic at first and then move to extinction monotony. These are the references. Thank you.
Hello.
Hello? What is the difference between theorem 1 and 2? Theorem 1 and 2 में क्या difference है? अब दो बनाए ना theorem 1 और 2. Mr. Pappu, you have a question? Hello?
Yes, sir.
What is the difference between your two theorems, 1 and 2?
First is sir for endemic equilibrium and second is for epidemic equilibrium. P1 represents for endemic equilibrium and P2 is for epidemic equilibrium.
And theorem 2?
For epidemic equilibrium, sir.
Okay, thank you, Pappu. You can make it clear.
Thank you very much, sir.
Miss Riya Mukherjee, you please continue.
Yes, sir.
First start your presentation.
visible, sir? Sir, the screen is visible?
Yes, yes.
Okay, sir. My name is Shreya Mukherjee. Good afternoon, everyone. My name is Shreya Mukherjee. I am a research scholar of Sindhu Manubirsa University, Purulia. My paper is Numerical Solution of Time Fractional Reconstruction Problem in a Fuzzy Environment. This is the content page. Fractional calculus is not a new topic. It was introduced before 200 years ago. It has been history as classical calculus. When order of a derivative of a differential equation taken as non-integer, then the differential equation is said to be fractional differential equation. In this paper, we used heat conduction equation in fractional form. This paper we used two-to-be analysis transform method. Two-to-be analysis method introduced by Liao in 1992. And when Laplace transform coupled with homotopy analysis method, then it is called homotopy analysis transform method. It is a very powerful method. In this presentation, we have used fractional homotopy analysis transform method in Fuzzy environment, and we will discuss the solution fractional conduction equation. Fuzzy number. Fuzzy number is an order pair of the lower bound and the upper bound. When the lower bound is bounded, it continues, non-decreasing, on-zero closed, and the upper bound is bounded, it continues, and non-decreasing, on-zero closed. The lower bound less or equals to the upper bound. Fuzzy function is a mapping from D1 impedance space of dimension 1 with non-fuzzy equivalent, and the perfect is defined by the lower bound and the upper bound. In this paper, we used fractional derivative in calculations. Capital fractional integral of order gamma of a function d fuzzy is defined as the order pair of the lower bound and upper bound, where capital derivative of the lower bound equals to 1 by gamma k minus gamma, integration is to x minus t whole to the power k minus gamma minus 1, the lower bound to the power k dt. When k minus 1 less than gamma less than k. When gamma equals to k, then dk or the lower bound dk. Similar for upper bound. Laplace transform on a fuzzy function, fuzzy is defined as capital F fuzzy, and it is also an order pair of the lower and upper bound. Now I discuss the algorithm of fractional homotopy analysis transform method in fuzzy environment. Here I choose the conduction equation where it belongs to 0 1 open interval and gamma belongs to open interval 0 1 closed interval. And fractional derivative is chosen in capital sense. Then using Laplace. Hello? Yes, sir. Is it visible, sir?
Please rotate your device.
Okay, sir. Yes.
Now quite better. Yes, okay, fine.
And then using Laplace transform, and we get that equation number 2. Then we choose nonlinear operator as of the form that when u belongs to 0 closed is an auxiliary parameter and sub fuzzy is a real value function of x, t, and u. The zero-order differential equation is given by Liao is in equation number 4, where xt not equals to 0 is an auxiliary function, u belongs to 0 closed is an auxiliary parameter, and h is an auxiliary parameter which is called convergent control parameter. When u varies from 0 to 1, then we get our approximate solution by initial solution. In using Taylor's expansion on sin quasi x du. With respect to u, we get that form. Differentiating the zeroth order differential equation with respect to u and taking u equals to 0, then we get nth order differential equation as of the form this. Then using inverse Laplace transform, we get our approximate solution, that is nth order. In this way, we sum all the approximate solution and all the solution and get our approximate solution P x d. When capital A tends to infinity, then we get better approximate solution. Since we work in Fuzzy environment, so there are two solutions, upper bound solution and lower bound solution. This is an example. This is the heat conduction equation in Fuzzy environment. With initial condition and exact solution are given. Round Fuzzy is a Fuzzy number. Then applying fractional homotopy analysis transform method, then we get that form. By using Fuzzy fractional homotopy analysis transform method, we get our approximate solution. This is the surface graph of upper bound and lower bound approximate solution and exact solution when delta equals to 0.1. Sir? This is the approximate solution and exact solution of upper and lower bound approximate solution when delta equals to 0.05. This is the free plot of upper and lower bound approximate solution. This is the H-curve plot of upper bound approximate solution. H-curve is called converging control parameter, and this is the H-curve of approximate solution of lower bound of the equation. This is absolute error curve of upper bound approximate solution, and here the absolute error curve of lower bound approximate solution. And we see that the absolute value tends to 0. We have used an effective iterative technique called fractional homotopy analysis transform method for finding upper and lower bound solution of Fuzzy time fractional conduction equation. By using this method, we can both solve integral and fractional order Fuzzy differential equation. To check accuracy and exactness of the proposed method, we have illustrated different graphs. The value of the arrow shows that there have been small difference between exact and approximate solutions. Therefore, from the full discussion, it may conclude that the fractional homotopy analysis transform method is very much powerful and efficient in finding approximate solution as well as analytical solution of many Fuzzy fractional differential equations. These are the references. Thank you.
তুমি এখানে আগে ওনাকে বলো, ঠিক আছে? তুমি এখানে বসো, তুমি যা বলবো তোমার মাইক্রোফোনে বলতে হবে না, তুমি যা বলবো না, তুমি মাইক্রোফোনে বলতে আমরা শুনতে পাবো। আসলে তুমি দেখো, এদিকে তো উনি শুনতে পাবেন, এখানে সবাই শুনতে পাবেন। উনি যখন শুরু করবেন এটা ক্যামেরাটা ওই দিকে অ্যাডমিট করো। Microphone down, microphone.
Am I audible?
Yes, sir. Please go ahead.
Okay. So actually, camera is not working in the laptop. So, is there any issue?
Sir, let me introduce you because the audience are waiting. So we,
Okay.
so ladies and gentlemen, we have with us Dr. Amit Majumdar, who is currently an assistant professor in the Department of Computer Science and Engineering, National Institute of Technology, Jamshedpur. He completed master's degree and PhD in Computer Science and Engineering from Jadavpur University. He has experience in teaching and research in different areas of computer science and engineering. He is also having experience to work as research person in workshop and training programs organized for students, scholars, and academicians. Dr. Amit Majumdar has authored many research papers published in journals and conferences. He has been serving as session chair, program committee member, and reviewer to some conferences. He is an active reviewer of few journals. He has been pursuing research in natural language processing, information, extraction, evaluationary, computation, machine learning, deep learning for the last 12 years. So we have our next keynote speaker, Dr. Amit Majumdar, and today's topic is Feature Engineering for Information Extraction in Bio-NLP. Thank you. Sir, please continue.
Okay, thank you for a nice introduction. Let me share the screen. Is it visible?
Yes, sir. It's visible.
Okay. So, good morning, good afternoon, everybody. Myself, Dr. Amit Majumdar, from NIT Jamshedpur. Today, I am going to present feature engineering for information extraction in bio-NLP. And these are the things I am going to discuss today. To start with this, I should mention what you mean by feature engineering. This feature engineering is related with machine learning. Actually, this is the technique by which we can develop a system which can do prediction, can be used to make some decision, can be used to predict in future. So for that, we need features to the system, and this machine learning is it's a data-driven approach where we need to provide data. The code or program is very less. It mainly depends on the data. So if the data is very good, the model that will be generated by machine learning algorithms can perform better. This feature engineering is necessary in case to process data written in natural language. So in today's discussion, my approach is to apply natural language processing on the data written in biological domain. So in biological domain, the data that or the literature that are available in the internet, from that literature, this today I focus on the technique to improve, to find out most relevant information. The data related to medical domain is increasing day by day. Internet has a huge volume of data. So from this huge volume of data, for a human being, it is very difficult to identify the most suitable information. So for that, we need to take the help of machine, which I will use to build a model based on machine learning. But when we are going to build a system on this type of data which are written in natural language, means either in English, Hindi, Marathi, different languages are there. So from that text data to find out the most useful information, we need to provide data in the format of features. So finding features is the most important part in bioNLP. And bioNLP is actually the interdisciplinary work which actually merges the NLP technique of computer science with the data available in biomedical domain. So it is an interdisciplinary task. Now, in the internet, when we say the data, data are in unstructured format. Machine cannot understand data which are in unstructured format. We need to provide data to the computer in structured format so that the machine can learn from that data. But how we can convert this unstructured data, like if we talk about the news, if we talk about in other audio data, video data, in different media available in the internet. So from this unstructured data, when the computer needs to learn something, it needs to be converted in a structured format. So let's first to define what we mean by features. I've already mentioned that data which is in unstructured format needs to be converted into a structured format, and for that we need to find out features from data. So data, when it is converted into the format of features, then the system can identify or can learn from that with some algorithms, maybe some ordinary machine learning algorithms, different algorithms are there with the decision tree, k nearest neighbor, support vector machine, which is very popular algorithm. So these are other different machine learning algorithms which can learn from structured data, and this learning can be in supervised approach, maybe unsupervised approach. Different techniques are there for machine learning. And today the technique that I will be discussing, it is based on a supervised approach with little bit using unsupervised approach. So it will be a combination of both. So I will discuss on this. And the format of data, it will be in this format. The data will be in the format of this number of columns should be here. Each column represents a feature, and each row represents one example. when you talk about the data set to build a model based on machine learning. Now, as the text data which are available in the internet, either in medical domain or in any other domain, so from that data, when we want to build a model, we need to extract features. And when after extracting features, actually the data will become in structured format. So there are different features which are commonly used in the task of natural language processing, like different maybe binary type of features, maybe categorical type of features, maybe numerical type of features. So this features needs to be extracted. Like whether whether one specific word, so to speak, is present or not in the text. So one thing I should mention over here when you talk about the NLP or bio-NLP, the data which are in unstructured format and mostly in text format, those text data, when we want to process those text data, we should consider one sentence at a time, and from that sentence we need to find out features. And for that, I will explain some steps are necessary, like in addition, then followed by features extraction from that. So these are the binary features, whether the specific word is present or not, what are the length of the text, whether this special symbols are present or not. So, and some categorical features may be there, like whether one word is long or not, whether the length is short length, medium length, or very long length. So there's a different type of categorical features. Also, we need to identify some features which will be presented as a numerical value, like how many words are here as a count of word, a particular type of word, except the core word. How many times this word is present? What is the length? It's a numerical value. So this type of features are necessary. This is one example how we can convert a sentence to numerical value. Like the length can be, if it is the binary type of feature, so the length of the sentence is more than 40 or less than 40. So we should consider the threshold value. It is not a text value. Based on experiment, we should specify or we should decide a value which can be considered the threshold value. And some numerical features based on the length of the sentence. If you want to have a less than 20, they need to be maybe considered the short type features. In between 20 40, it may be, and then if it is more than 40, it is the long type of features. And then from this categorical features, actually, when we talk about the categorical features, still the data will be in the format of category, not in the format of number. Actually, machine learning techniques makes the data in the format of number, not in text. So from text data, somehow you need to generate features in the format of number. When you talk about categorical features, it is in category not in number format. Binary type of features is mainly in the format of yes or no, which also not in numerical format. But you should convert all this in numerical format, because the machine learning algorithm expects that the data that you provide to the algorithm, it must contain numerical value in feature format. So from categorical data can be easily converted to numerical format, which while we need to use one-hot encoding. But every feature means for a particular features, if there are three categorical types, then it will have an encoding of three values. And for that particular means for every category there will be a slot in this stated value. And if the categorical features is short, then what the corresponding value will be one and another. So this is for the one-hot encoding, which is very popular. convert text data to numerical data. And finally, this type of features can be easily converted to 0 and 1. For this, you may consider 1, for no, you may consider 0. And this is the other feature engineering technique which are very important in any natural language processing. That you need to tokenize the sentence, means the sentence has to be stated into a number of words, that is the tokenization. And the bag of words, it contains it is a list of all the words. Actually, the bag of words you need to form one dictionary of unique words, and then for every word present in one sentence, it needs to use one word encoding in bag of words which are formed. Income is I will discuss with whether the implement here by the term frequency, inverse document frequency. This type of features is very important, and it has been seen that with the help of this term frequency and inverse document frequency, the performance of machine learning model can improve. Term frequency is the number of means how many times a particular word is present in one document. And when you talk about the data set, it will have a number of documents. So considering all documents, we need to find out document frequency, means how many documents a particular word contains. And for that, it has a specific formula to find out this value. And next, a very important technique of feature engineering, which is used actually in deep learning, that is embedding. The tokenization, bag of words, TF-ID, this type of features are used in normal machine learning approach. But embedding technique is used in deep learning. And embedding is a technique I will discuss in detail. The embedding is a technique by which one word is represented in the format of a vector consisting of a number of arrays. And that is nothing but a feature representation of the word. And with the help of embedding technique, we can perform we can apply mathematical operation on word. So that is the embedding technique. So, hello? 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 Am I audible? Can you hear me? Hello? Hello, is it? Am I audible clearly? Hello? Okay. Is it okay now?
Yes, sir.
Okay, because some noise was coming. That's good. So, again I am sharing. So this is the approach I already mentioned. I am skipping this word. So this bag of words technique, when we want to process text data, which is in the format of sentences, like if you want to do analysis of text data, like the sentiment analysis. Whether the sentiment is positive or negative or neutral. Like if I want to collect some opinions about some current prime minister, then the processing of those opinions can be done with the help of natural language processing, and we can, after building a model, we can decide whether a new opinion be considered as a positive type of opinion or negative type of opinion or neutral type of opinion. For those type of application, this backup words can be used, and it is not so very complicated. Suppose you have a number of messages. This is one message, another message, third message, fourth message. Now in backup words, you need to find out a dictionary from all these messages, and each message is considered as one example. And you need to find out one dictionary which contains the unique words, and this is the list of unique words. And in backup words, when we are going to represent this example or one message, for each word, like the A word, it will contain, it will be represented actually in terms of one word encoding. And how it is done? So this way we represent. Like suppose this is the sentences and this is first message and the word, so this is the X1 is a word, X2 is word, X3 is second word. So this is the list or dictionary of words, and for each word actually each word will be considered as a feature, and this way each message will be encoded in the help of numerical elements for the feature will be one or so. So this way the messages or the text data needs to be converted when we are going to apply for picking machine learning. So this is the representation, and once you convert this text data, we are considering three documents. The first document is simply a sentence, second document also sentence, third document, and for each document which is considered as one example, you need to build this type of representation. That's called a feature representation. Once you build or convert this data in the format of this feature representation, then you can provide this data to the machine learning, to the algorithm for machine learning, and the machine learning model can be generated, and then that can be used for testing any unknown message or any unknown example or any unknown document. So I am skipping this part. So these are the ordinary machine learning approaches which are used. The most important part is the embedding, which is used in deep learning, and the technique which are used in embedding the what to get is one very popular algorithm and fast text, because this are used to represent the words of a sentence in terms of feature value. That's called a feature vector. And this what to get, it performs operation in word level, whereas in case of fast text, this is another technique for generating the embedding, where it uses word embedding along with character embedding. Because actually the word embedding cannot capture the complete information, because it may happen when you write one unknown document or unknown sentence to a model. That unknown sentence or document, that's considered the test data, may contain some words which are unknown to the model, because during training purpose the model has not seen that type of word. So for that it is necessary to contain some content information of the word, for which it needs character encoding, also called the character embedding. So actually this embedding technique is used to remove one disadvantage of one-word encoding. Because what happens if your data set has one lakh word, then in case of one-word encoding, every word is represented by a feature vector of length 1 lakh. While only one value will be 1 and all other values will be 0. That is one-word encoding. And when this data is stored in memory, it's stored as it's loaded in memory, it will consume memory. takes lots of space. And also the performing operation on data will take time. And actually the main limitation of this technique is the cost of dimension, because it is data set will have huge dimension. To remove this difficulty, the embedding technique is used where each word is represented by a vector of numerical data. And this representation is done with the help of neural network. And for that, they are running the word to vec. So this word to vec uses neural network where it considers some context information to predict one word. So two approaches are there. So I am skipping these two approaches. One is, so this is the approach, one is the continuous back of words technique and the skip grammar. So these are the two models which are used for word embedding. Another popular embedding is the technique that is the global vector. And so this is all embedding technique. So what to vec or globe is the two popular techniques for representing word as a vector of feature marks. Now, for this technique to find out the embedding, the approach is first you need to, when you have document in the format of sentences, first step you need to organize this in the breaking the sentence in terms of a number of words. It may have t number of words which are called token. So this is called the tokenization. After tokenization, each token needs to be represented as a collection of feature value of one specific dimension, that is called dimension T1. And when you have t number of words or token and each word is converted to a T1 dimension of embedding, then the total dimension of this data will be T1 by capital T, where capital T is the number of tokens. So this way the word level embedding is done, and for this again I am telling, for this conversion from word to this picture vector representation, it needs one neural network. And in this technique, it uses neural network, and the approach of learning is self-supervised learning. Then from the sentence itself, it will use supervised approach. That is very explicit tagging of the example sentences. From the sentence, how it is done actually? For each word, actually it needs to find out what is the nearest word, previous and next word, which is called the contour, which is called the window, surrounding window, context window. From this context window, it tries to find out if it has some surrounding word, then what would be the predictive. And the two approaches are predicting the middle word by considering the surrounding word. Another is considering only the middle word, find out its surrounding word. Surrounding maybe two surrounding previous two words, next two words, or only previous one word, next one word. So that's defined by the size of context window, whether you consider two words or three words or one words. So that depends on the technique, whether what is the size of the window that you consider. So during learning of this embedding, you need to specify the size of context window. And this is the character embedding, where every character is represented by a feature value. Then this two embodies needs to be converted. So I am not going to, because it needs time to explain these things. So what I am going to explain over here, See, when we are going to process data which are in natural language format in biomedical domain or in any other domain, if this word embedding and character embeddings are very important, which captures the context information. Context information with the help of another encoding that's called the contextual embedding. And this contextual embedding is implemented with the help of different algorithms, which is also as the deep learning approaches. That the LSTM can be used, long short-term memory can be used to find out this representation. Or we can use the forward LSTM, backward LSTM. So this is the deep learning algorithms. So I'm just going to state this part now. In now to extract the now when we are going to apply this embedding techniques or in-gram techniques, back-and-forth techniques on data represented or environmental domain, we need to extract these features either in the pure features for ordinary machine learning approach or the embedding vector of words or sentences. So those informations are necessary to build a model to extract most useful information from biomedical domain. Hence the literature or the text data available in the internet in biomedical domain. So different types or different organizations are involved in this process. Already many conferences are organized previously. And one important series of this text mining on biomedical domain is the biomedical, which had started from 2019 onwards. And biocreative, this is one trust and trade. So these are different organizations which are related with this type of trust related to biotext mining or biolinking. And the main important tasks available in this are the useful information, extraction, find the interaction, protein-protein interaction, find out the named entity from biomedical text data, making a summarization from biomedical text data. So these are different application areas available in text mining. Let's consider one example sentence in biomedical literature. Like this, in this study, we hypothesized that the phosphorylation of PrAT to inhibits binding to CD40 cytoplasmic movement. So this is one example sentence in bioenergy. Now from this sentence, if I want to extract most useful information in the format of bio event, then we need to have a data set where we need to specify the proteins, genes, which are considered the named entity, and the action which are performed on this type of product, proteins or genes. So then this data set, this should be mentioned, and here that is the phosphorylation, this is the type of action which are performed. So for this, actually this is the annotated data which needs expert in the field of biomedical. So those experts actually build this type of data set as a computer science background, as a computer science researcher or the machine learning or in deep learning researchers. So they can use those annotated data set for building a model to identify the most useful information. So I'm not going to explain into this. And one important part that is available, the abstract data or abstract of the literature which are available in PubMed, and it is currently it has more than 37 million of abstracts of literature in biomedical domain. So from this use literature to extract most useful information, we need to take the help of computer to build a model based on machine learning. And in this work, the dependency embedding that in our work we consider this dependency embedding, where the dependence it needs the dependency cursor to generate this type of graph, which actually contains the relation between different words in a sentence, and for each word we can extract more meaningful information so that the machine can build a better model. So this dependency information will help to improve the performance of machine learning model. So this is from the embedding that we used, the word embedding, character embedding, dependency embedding. And so this is actually for every word of the one sentence, we extracted the dependency relation, and the dependency relations, this dependent relation will find out the dependency embedding, which will capture most useful information. And this actually improves the performance of the model. So this is the network that we considered, that this is the list in the network we should provide words as input, and it will follow a number of embeddings, that the first word embedding, then character embedding, then dependency embedding, and this all those three embeddings will be merged to create a long embedding. Then after getting this embedding, we need to get the contextual information. We need to use the LSTM, bidirectional LSTM have been used over here, where the sentence is processed from starting to end and then from end to start to capture more information and to build a better model. So this is the more which is very useful architecture. And this is the parameter that we developed used in this work. So embedding is, so from the experiment that have been done so far, it has been seen that dependency embedding is very important, along with word embedding, character embedding. And these are the some available tools available in internet, which provides you, which will help you to find out some meaningful information, like the POS tagger for English available, and also in biomedical domain, another tagger which is tuned with the data of biomedical domain, that's called a linear tagger. So you can go for this type of tagger to extract the tagging information which can be used in processing text data. And also parser is needed. You have seen the dependency parser is needed, which will provide the dependency relation within the words in a sentence. So these are EMG parsers, CMG parser, linear tagger. This also parses data and can provide you the dependency graph or dependency tree. So which will be processed to find out information which are necessary to build the model. And other tools, so this is the event extraction in biomedical domain. That's the one important tool is the event mine, which is already available, so we can use this to extract the most useful information. For named entity also we can use the linear tagger, which is very helpful. And these all these tools are available, and these tools are tuned with the data of biomedical domain. So in depends, this is not necessary, and another we say to improve the performance, these are some techniques that transfer learning can do. Transformer-based learning is very important nowadays. And you know the BART system, BART can be used in this type of work. And to build a better model, to improve the performance of the system, based on machine learning, you can apply subcomputing approaches, where you can use the genetic algorithm to improve the performance of the system. To select the best set of features, but means genetic algorithm can be used for feature selection purpose. So these are the techniques you may go for, and you may try these techniques to build a model in will the domain reach that most useful information. So this is all about and thanks for questions and attention. So
Thank you so
any
much, sir.
question?
If any of the audience have any question? No, sir, don't have any question. And thank you, Dr. Mojumdar, for sharing and delivering such an informative speech by enlightening the field of machine learning and language processing. Sir, your valuable appearance in our conference really added some multi-dimensional knowledge to us. Once again, thank you so much, sir. Thank you.
Thank you. Thank you. May I leave now?
Yeah, you can let us know. Thank you.
Okay. Thank you, everybody.
Thank you, sir.
जो जॉइन होने दीजिए, प्लीज वेट.
Okay.
उधर से नहीं.
बाकी का तो अपना व्यू पर अंकित कुमार आप स्टार्ट कीजिए अपना प्रेजेंटेशन.
Good evening, sir. Good evening, teachers. First of all, thank you all for giving me the opportunity to represent my work in front of you. Now I will share my screen. Sir, please make sure it is visible.
Yes, visible.
My topic is a mathematical model for future pandemic replacement based on the WHO pandemic case. I have done some more of it. Please forgive me for unusual things or words written by me by mistake. Mathematical modeling for pandemic, I have extracted some data. First of all, I will show you the threat for upcoming pandemic. We have three scenarios. The present a commit threat of the any other viruses that will be more dangerous to coronavirus, which has just passed 2 years, 2 to 3 years. And proceeding further, I will show you the WHO framework of this model. This is the data for the death of all of the viruses till now. The smallpox virus, which causes more than 300 million deaths. Black death, that is 225 million deaths. But corona COVID-19 has caused just 4 to 7 million deaths. That is very less number in comparison with the previous days. And that is these viruses where organization has divided this pandemic phase into 6 phases. Phase 1 indicates that the during pandemic flu virus, especially influenza, separated among animal and birds have been reported for human infection. And phase 2, the influenza virus is separated among domestic animals or wild animals, causing infection in humans. But the virus has potential threat. In phase 3, human animal influenza reborn virus has now resulted to human transmission. That is, in phase 3, the virus has increases transmission in human. And the human transmission occurs only by close contact with the infected person and the unprotected body. Still, the virus does not get the level of cognitive threat during this phase. But in phase 4, human animal reborn virus has the capability of community level outbreak and high risk of pandemic. Affected country must consult to the WHO so that situation can be jointly assessed. Phase 4 indicates significant increase in the rise of pandemic. In phase 5, the human spread of the virus has increased in the community level, and WHO has recognized 2 countries in one region. Like example, if you take the Asia, 2 countries in Asia, like it is spread in India and that is also Sri Lanka. But it has not spread over the world. But in phase 4, the virus has spread over the world and the other region also, that is Asia, Europe, America and all. And the indication was like that the virus may cause global pandemic. I have characterized these notes on the base of the infections, and here the green mark represents the recovery, and red marks indicates the infected person, and S marks indicates the suspected one. We have 2 models, that is SIR model and SIS model. I will explain separately both of the models. I have made the cluster formation of these viruses, how they are affecting the others, and due to migration and in contact. This is the cluster formation of community, that means how people are traveling from one place to another place, causes infection, and suspected people are also increasing. We have 3 models, 3 clusters over here. Next, I will increase the what is SIS model with mobility. That means the SIS model has 2 sets of states and 2 sets of rates. Sets of states contain susceptible and infected person, and set of rates has the infection rates and cure rate, that is recovery rate. Systematic representation. Here we have the dynamic representation for the calculation of. Here mu1 is the rate of mu1 and beta1 is the rate of infection from the suspected one person, and theta is the rate of migration of infected people from one cluster to another cluster, and phi is the rate of migration of suspected person from cluster 1 to cluster 2, and gamma 1 is the rate of recovery from infected person. In cluster 2, we can see that mu2 is the rate of newborn, and beta 2 is the rate of infection from suspected person to infected person. And again, theta is the rate of migration from cluster 2 to cluster 1, and phi is the rate of migration from cluster 2 to cluster 1, and gamma 2 is the rate of recovery from cluster 2. We have taken the basic reproduction number, that is R0. R0 is the most important threshold condition in pandemic model. are not defined as the expected number of secondary infections produced by a single infected total system susceptible population. Are not determines whether the infection person persists as an epidemic or die out with the time. We have two cases with R0. If R0 is less than 1, then the infection die out and the disease equilibrium is stable. And when R0 is greater than 1, then the infection persists and the endemic equilibrium is found to be stable. I have calculated the value of R0 as R0 I is equal to beta I by gamma I plus mu1. Now I will show you some graph presentation where first of all I will show you when R0 is equal to R1 is equal to R2 and that is less than 1, then we can clearly see that the graph represents the infection has comes to 0 at some point. And when R1 is equal to R2 and greater than 1, then we can see that the infection rate has increased rapidly and it is constant at some point that is greater than 0. Now I will show you if any one of R1 or R2 is greater than 0 or less than 0, then the graph has the rate of infection has increased rapidly and it has constant value at some other value greater than 0. Now I will show you how the mobility impact the spread of the infection. That is, if the rate of migration of infected person and rate of migration of suspected person is at constant, that is 0.08, then we can clearly say that rate of infection is increasing. Okay, sir. It is just one purpose slide left, sir. Here we can clearly see that the rate of infection is increasing very rapidly and it is constant at some other value greater than 1. That is, infection is increasing. If we take the rate of infection, rate of mobility of infection is very less than the rate of mobility of suspected, then again we can see that rate of infection is increasing very rapidly. And if we take the rate of migration of infected is much more greater than rate of mobility of suspected one, then again we can see that rate of infection is increasing. That is, in all the cases rate of infection is increasing. Now I have reduced the system in two equations and as follows. And the Jacobian of the system is this, and we have the characteristics equation as follows, and the value of lambda will be the characteristics rules. Expected behavior according to the new condition, I have made a table that is if a plus b is less than 0 and ac minus b square is greater than 0, then the sign of the eigenvalue will be greater than 0 and sum of the eigenvalue will be greater than 0 and product of eigenvalue will be greater than 0. That means both will be the nature of the eigenvalue will be negative and nature of stability will be attractor. If a plus c is greater than 0 and ac minus b square is less than 0, then sum of eigenvalue will be less than 0 and product of eigenvalue will be again less than 0. That is, both are of opposite sign. That means stability has a saddle point. If a plus c is less than 0 and ac minus b square is less than 0, then sum of eigenvalue is greater than 0 and product of eigenvalue is again very less than 0. That is of opposite sign. That means stability again has the saddle point. If a plus c is greater than 0, ac minus b square is greater than 0, so then again we can see that sum of eigenvalue is less than 0 and product of eigenvalue is greater than 0. That means both positive. That means nature of stability is repellent. According to these tables, I have made some graph again. If we see that a plus c is less than 0 and ac minus b square is greater than 0, then 0 is the attractor. And in the case 2 and case 3, you can see that 0 is the saddle point. And in case 4, 0 is repellent. Now these are the references. Thank you, sir. Thank you all.
Thank you, sir.
Hello, Mr. Ankit. Is audible to you? Hello, Mr. Ankit. Hello, Mr. Ankit. Is audible?
Yes, sir. I am audible, sir.
Very good and serious topic you have selected. Definitely, the people in the future will get benefited.
Sir, your voice is not clear, sir. Please repeat, sir.
Sir, please come
Yes, sir. I am using headphones, sir. Please.
Now it is okay.
Yes, sir. Yes, sir.
My question is, in your model, what kind of input data you have selected?
Sir, I have some data regarding the pandemic phases, and I am representing it. I have taken this data as reference. I have given reference also, sir, for this data.
Your work is very good. For general people, how you convince them it is very informative and what are the information you want to give to the general people?
Sir, I just want to give information that if rate of mobility is whatever is the rate of mobility, it is positive, then the rate of infection will increase.
Thank you.
Hello.
Yes, sir.
Hello. What is the procedure to determine the rate of suspected rate of
Sir.
Hello.
It is not audible, sir.
From which equation we move and determine the rate of disease of suspected person?
Sir, please, question I cannot follow.
From which question
Yes, sir.
Hello.
From which question I?
In your slide, you show the rate of disease of suspected person. From which equation you can determine?
Sir, again I
find out the equation for the rate of disease.
Rate of disease.
Yes.
Yes, sir. I have these two equations, sir. Yes, sir. I have reduced the four equations in two equations, sir. Here I have taken only infected equation and infected 1 and infected 2, sir. Suspected equation I have substituted to this equation, sir. Reduced to this equation.
Okay, thank you.
Thank you.
Okay. Thank you for.
Okay, sir.
You please finish your presentation. And now Chandan Pandit, you please start. Mr. Chandan Pandit, are you there?
Yes.
Yes, you please present your presentation.
Yes, sir. Good evening, sir.
Yeah, it's fine. Start.
I'm Chandan Pandit, a research scholar from University Department of Mathematics, University Gujarati, and the topic of today's presentation is assessment of historical and future rainfall and temperature of large for a period of 35 years. So let's talk about introduction. So the rainfall in India is heavily dependent upon the southwest monsoon, which runs from mid-July to mid-September. Monsoon rainfall of India contributes nearly 75% rainfall to the annual rainfall. However, there is large variation in the temporal rainfall. According to the fifth environment assessment report of IPCC, the average worldwide combined ocean temperature rose by 0.85 degrees centigrade between 1892 to 2012. Then the warmer climate is probably going to result in more heavy rainfall, which will probably come from the fewer but stronger occurrences. So the changing pattern of rainfall and temperature has gathered eyes from the whole world, and researchers around the globe are working on the forecasting of these events to understand the upcoming pattern and variability. The forecasting of rainfall and temperature can be done by several methods such as interpolation, full winter exponential method, and ARIMA. And rainfall of Ranchi was forecasted for the year 23 to 30 using full winter exponential method. But in this paper, I have done the historical rainfall and average temperature that is analyzed for trend, variability, and correlation for the period 1975 to 2023. And then I have forecasted from the period 2024 to 2050 using ARIMA model. Also, the forecasted rainfall and average temperature have been analyzed for possible trend. So, what is methodology? So, first the daily rainfall and daily average temperature data for the study area Ranchi for the period 1975 to 2023 are obtained from the National Center for Environmental Information. And then from this daily rainfall and average temperature data, monthly, seasonal and annual data are calculated. Then for the trend analysis, I have used Mangander and Saxford method. And for the shift point detection, I have used Mangander Snail sequential test. The correlation analysis of rainfall and average temperature are done using Pearson correlation test, and the forecasting was done using Riemann. The Mangander test is basically a non-parametric test which determines whether there is a trend or not in the data set. So it tells us that is there upward trend or downward trend or no trend at all. So this means that first we try to find the indicator first, so which is sigma of xi minus xj, where xi and xj are the data points, and then from this we find out the value of Mangander test static z. So here we can see that this z depends on the value of s, and if there is greater than 0, that represents monotonic upward trend, and if there is less than 0, then that represents a monotonic downward trend. However, we see that z is like more than 2, then we say that this is statistically strong trend. And together with Mangander test, we use Saxford method for the trend analysis. And for the forecasting, I have used Riemann model, which is auto-regressive integrated moving average. So it is comprises of mainly 3 components, which is auto-regressive, integrated, and moving average. So the auto-regressive component indicates that the evolving variable is replaced on its own length value, and that moving average component shows as a regression error. Riemann model are actually denoted by PD, where this P depends the number of auto-regressive order, D is the order of differencing, and Q is the number of moving average order. Here we first try to find out the value of D, as this Riemann model requires the data set to be stationary. So if our data is non-stationary, then first we try to find the differencing which makes the data stationary, and we fix the value of D in this Riemann PDQ model, and we value of P and Q, and find a suitable model for the data set. And the mathematical portion of this is written here. Now for which Riemann model is based, we decide on the basis of this normalized VIC value. So the less value of normalized VIC value signifies that the model is more accurate. And I also use Mangander snare test for the know the change point, shift point of the trend. So it tells sudden change in the significant trend. So let's talk about some results. So first, the mean rainfall for the period 1975 to 2023 is 863 mm with a standard deviation of 406 mm. The coefficient of variation indicates that the yearly rainfall has 47% of variation, where monsoon rainfall has the least variation of 51% among the seasonal rainfall, whereas winter rainfall has the large variation. If we talk about the monthly rainfall, the least variation is observed for August, which is 65% among the monthly rainfall, and the highest variation is observed for November. The maximum rainfall is observed in monsoon, which is 79% always of the yearly rainfall, and if we talk about monthly rainfall, then August has the maximum rainfall, which is nearly 24% of the annual rainfall. And the minimum rainfall is observed in winter season and in the month December. The mean average temperature for Ranchi for the year 1975 to 2023 is 24 degrees centigrade, with a standard deviation of 0.45 degrees centigrade. And we talk about the variation. The least monthly variation for average temperature is observed for August, which is 1.87%, whereas the highest variation is observed for February, which is 6%. So this is the table where we can see in the bottom that the annual rainfall has the mean of 863 mm, whereas the average temperature has a mean of 23.992, which is 24 So let's talk about the trend analysis. So for the trend analysis, I have used Manhattan list, and here it is the statics of Z. I have also mentioned the trend by PT I mean positive trend and by NT I mean negative trend. So here we can see that the month of June, July, August, September, October has the positive trend for the rainfall. And if we talk about the seasonal rainfall, then monsoon has positive trend, whereas annual rainfall has also positive trend. If I talk about average temperature, then only August has positive trend of temperature. So the monsoon and annual rainfall have significant upward trend, and no other season have any significant trend. And the shift point for the increasing trend for monsoon and annual rainfall is 1993 and 1996 respectively. For the actually monsoon is increasing from 1990. So in this graph I can see from in this right hand side in the figure B, this is the curve of monsoon rainfall shift point. So here we can see that the two curves are crossing each other at 1993, and in the left hand side we can see that the two curves are crossing each other at 1996. So this is the point of shift point. So the rainfall pattern started to move in upward direction significantly for monsoon and annual rainfall from 1993 and 1996 respectively. The monthly rainfall of June, July, August have significant positive trend, and no other months have any significant trend. And seasonal annual and average temperature and rise for possible trend, and there is no significant trend change for seasonal or annual average temperature. However, the monthly average temperature of August has significant positive trend. So let's talk about correlation analysis. So in this correlation analysis, I have tested the interdependency of rainfall and temperature on each other. So the seasonally summer rainfall is negatively correlated with summer average temperature at 95% confidence level, and annual rainfall is also negatively correlated with annual average temperature. So basically this means that if summer average temperature is increasing, then summer rainfall will decrease, and if annual average temperature is increasing, then annual rainfall will decrease. And monthly, if we talk about, then rainfall and monthly average temperature have negative correlation for March, May, June at higher confidence level, and at some lower confidence level, July, September, and December also. So this is the table for that. Here we can see that the March has the correlation of minus 0.536 with a significant value of 0, which is highly significant. So I have analyzed this, and now we talk about the forecasting. So seasonal and yearly rainfall and average temperature are forecasted for the period 2024 to 2050 using the most suitable time model, and the suitability of model is decided on the basis of normalized VIC value. So the historical rainfall and average temperature data from 1975 to 2023 are used to train the model. And it is seen that the ARIMA 011 is found to be the most accurate model. So I have highlighted the wrong this model. So in the second row we can see that ARIMA 11 has the least normalized VIC value, which is 9.726. And for the average temperature, the normalized VIC value is negative 0.401. So this ARIMA 111 is the most stable model. And from this ARIMA 011, I have predicted the rainfall from 2024 to 2050, which is not mentioned in this slide. Then from that data set of the forecasted rainfall and forecasted temperature, I have done the trend analysis of forecasted rainfall. So trend analysis of forecasted rainfall and temperature suggests that positive trend is present on summer, monsoon, post-monsoon and annual rainfall, whereas negative trend is present in winter. Also, the trend analysis of future average temperature has positive trend for monsoon and rest seasons and annually trend is negative. So, this is the trend analysis for the trend analysis. So, positive trend is present in summer, monsoon, post-monsoon and annual rainfall, whereas winter has negative trend. And if we talk about temperature, then summer has negative trend. Post-monsoon has negative trend, winter has negative trend, and annually it is negative. So, the conclusion part. So, the historical rainfall for this period has been analyzed, and the annual mean rainfall is 863 mm, and with annual mean temperature is 24 degrees centigrade. Monsoon and others contributes the highest rainfall to the annual rainfall, whereas winter and December month contributes its least rainfall. Trend analysis of rainfall suggests that significant positive trend is present for annually monsoon rainfall, June, July, August, September, and October months rainfall. However, trend analysis of temperature has significant positive trend only for August. Correlation analysis suggests that a negative correlation exists for annual summer, March, May, and June at 99% confidence level, and for July, September, and December, 95% confidence level. Here we can see that the correlation suggests the only negative correlation, means if temperature will increase, rainfall will decrease. Okay? For all these significant correlations. Then Arimadhi-Roman is found to be the most accurate model for the prediction, and the best fit model is selected on the basis of normalized PIC value. So the trend analysis of future rainfall suggests positive trend is present in summer, monsoon, post-monsoon, annually, and whereas negative trend is present in winter. Also, the trend analysis of future average temperature has positive trend for monsoon and rest season, and annually trend is negative. Thank you.
Hello, Mr. Chandan, it is audible. Mr. Chandan.
Please mute the
Hello. Chandan, are you getting me? Hello.
Is it fine, sir?
Hello, Chandan, are you getting me? Hello. Hello, Chandan. Hello.
Yes, sir.
It is audible to you.
Yes, sir.
Very properly you have presented your all the slides was very informative. My question is, you have worked in the Ranchi region on the rainfall. So what
Sorry, sir.
are you getting?
Yes, sir.
So my question is your work particularly for the Ranchi region or it is applicable for anywhere in India?
Sir, all the analysis have been done for Ranchi, but this can be actually I have used the data of Ranchi, so that's why this is only for Ranchi.
Suppose I will take the region like Meghalaya where heavy rainfall is there. So what kind of changes has to be made?
Sir, basically for the forecasting, I have used the historical rainfall data. So there is no actually changes to be made for data. But yes, the model has to be taken that which Parima model is best suitable. So it depends on the value of the data.
Okay, very good, very good. Okay, thank you. Thank you.
Mr. Jitendra, please start. Mr. Jitendra.
Yes, sir.
Please present your presentation. And try to finish within 3 or 4 minutes maximum.
Okay, sir. Good evening, sir. Am I audible, sir?
Yeah, it is audible. Continue.
Hello.
Yeah, you are absolutely audible. Continue.
Yes, so start.
Yes, sir. Yes. I'm Engineer Kumar from Innova University, Hazaribagh, and pursuing PhD under the supervision of Dr. Cmaes, sir. My topic is some particular cases of Rajah's conjunction, and these are the parts of my presentation. My work is on particular cases of Rajah's conjunction. First of all, we understand this presentation deals with a brief history of Rajah's conjunction and its development. Some proofs in special cases are included with detailed examples. The method used is expressed mathematically and can lead to the generalization of the process. These are the keywords. Before going to start our proof, there are 3 definitions. First, Harmon matrix. A matrix H with entries plus minus 1 is said to be Harmon if product of matrix H and its transpose is equal to n times the identity matrix of that particular. There are some examples of Harmon matrices of order 1, 2, and 4. And what is circular matrix? A matrix is called circular if it is generated by its first row and every subsequent row is obtained by the right cyclic shift of the previous. These are the examples of circular Harmon matrix. Circular matrix. If a matrix with first row is 1, 2, 3, 4, then its remaining row will be 4, 1, 2, 3, 3, 4, 1, 2, 2, 3, 1, sorry, 2, 3, 4, 1, respectively. Circular Harmon matrix. A Harmon matrix which is also a circular matrix is called circular partial Harmon matrix. These are the examples. Some facts on circular Harmon matrices. The only known circular Harmon matrices are of order 4. Second, circular Harmon matrices are row regular. And third, if there is a circular Harmon matrix of order n, then it will be under root n row. If there is a circular Harmon matrix of order n, then n will be 4h square, where h is any or integer. And some facts on circular Harmon matrix are this. And the next point is axial Rajah conjecture that circular Harmon matrix does not exist of order n greater than 4. My main work is based on this conjecture. Rajah's conjecture, history of Rajah's conjecture, and some words on this topic. My work is start from here. Non-existence of circular Harmon matrix of order 6. An elementary approach has been used in this presentation to prove the Rajah's conjecture of a specific order 60. We have supposed that there exists a circular Harmon matrix of order 60, and then this matrix will be H circular x1, x2, x3, dot 60. It is the first row of the matrix H, and by the property of Harmon matrix orthogonality, inner product of the
Hello. Hello, Mr. Jitendra.
Hello, Jitendra. Is it okay? Hello, Jitendra.
Hello. उसी का तरफ से प्रॉब्लम है सर, उसी का तरफ से प्रॉब्लम है, वही आउट हो गया। नहीं, सेकंड लास्ट सर, एक बार इनका शुरू कर दे, इनका वो आउट ही हो गया।
Hello. Yes, sorry, sir. Yes, sir.
No, it is okay. Continue. Where you have left.
The slide you left, please continue from the
Yes, sir. Yes, sir. Okay. My main work is start from here, and already I have support that there exists a circular transform matrix of order 16, and I have started use some properties of circular transform matrix and try to find whether why it does not exist. And I have support that H is a circular transform matrix of order 16, and by the property of orthogonality, the inner product of first and ninth row is 0. We call it the equation. And the property of circular transform matrix is sum of any row is equal to under root L. And here my N is 16, so under root 16 is equal to 4. So same equation. Equation 1 implies that. Equation 1 implies 3 points. There are 4 pairs of the type xi plus 8 have opposites, and second is there are 3 points of the type xi plus 8
having same positive sign. And third is there are one pair of the type xi plus 8 having same negative sign. After inner product of first and second row, we will get equation, and by the property of orthogonality it should be 0. And next inner product of 9th and second row will also 0 for equation 4. Adding these two equations, equation 3 and 4, we will get this result, and due to orthogonality this also will be 0. After simplification of equation, this previous equation, we will get equation 5. And equation 5 will be these 5 possibilities. First is, if I is if I is odd number, then only 4 pair are opposite, then and opposite sign pair of where I is even is 0, then equation 5 is satisfied. And when there is no pairs having opposite sign for all I, and opposite if I is even and all odd pairs are from there, then equation 5 is also satisfied, and in the remaining 3 cases equation 5 will be not satisfied. This table implies that the opposite sign pairs are either all odd pairs xi plus 8 where I is odd, or all even pairs xi plus 8 when I is even. Also from the inner product of row 1 and row 3 we have equation 6. Consider the two cases. If opposite sign pairs are xi plus 8 where I is odd, then the sign asking for the equation 6 are this. First circle is for odd numbers and second circle is for even. Any pair xi plus 8 for odd I in the north or circle A can interchange their sign as plus, maybe negative minus, and minus may be interchanged with plus. In circle A, fix any pair xi plus 8 in such a way that there is opposite sign in the LHS and RHS of xi, and there is opposite sign in the LHS and RHS of xi plus 8. Also, the number of sign change in the LHS between xi and xi plus 8 is equal to the number of sign change in the RHS. This implies the absolute value of the sum x1, x50 plus x1, x3 plus x1, x5 plus x13, x15 equal to 0. And for the circle B, the absolute value of the sum will be 0. And since 4 plus 0 equal to 4 not equal to 0, which is a contradiction, hence case 1 is not possible. In other case, if opposite sign pairs are xi plus 8 for I even, then sign scheme for equation 6 are this circle. Circle C is for odd numbers and circle B is for even numbers. And any pair xi plus 8 for even I in a graph C can interchange their sign as plus, maybe plus and minus, both can interchange. In circle C, fix any pair xi plus 8 in such a way that there is an opposite sign in the LHS and RHS of xi, and there is an opposite sign in the LHS and RHS of xi plus 8. Also, the number of sign changes in the LHS between xi and xi plus 8 is equal to the number of sign change in the RHS. This implies the absolute value of the sum of this previous circle will be 4, and absolute value of the sum of the circle D will be 0. Since 4 plus 0 equal to 4 not equal to 0, which contradicts which contradicts our supposition, hence case 2 is also not possible. And from the conclusion is the proof presents a completely algebraic approach to Rayleigh's conjecture, contradicting the sign pattern represented by circles, the evidence consisting the sign pattern by circles. The evidence based on sign pattern is a new approach to prove Rajah's conjecture for a 60. However, this idea involves some complexity for the next possible order. However, we can prove the same with a few improvements for the next possible order. The main focus of the representation work is the generalization of the approach used to prove Rajah's conjecture. These are the references, and this completes my presentation.
Hello, Jitendra. Hello, Jitendra.
Yes, sir. Yes, sir.
My question is, where Rajah's conjecture is used?
Yes, actually, Rajah's generally concept of Rajah's conjecture and Surcon matrices and Harvard matrices are used in coding system.
Okay.
Coding system, and in recent ETL used it in MRI system, which gives the function of brain.
Is it related to machine learning and all that?
Please repeat, sir.
Is it related to machine learning and all that?
I think I have no idea about this, but recent, yes, sir.
Okay, okay, thank you. Thank you.
Thank you, sir.
Now, Bharti Anand,
Thank you.
you please present. Bharti Anand, are you there?
Yes, yes.
Please share your presentation. Start.
Okay, Jitendra, you can quit.
Sir, is my screen visible?
Not yet.
No, it is not visible yet.
Share the presentation.
Is it visible, sir, now?
No, still not. Put your slide in projecting mode.
Yes, sir, presenting. Select a tab to share. Yes, sir.
Hello?
I have opened it, sir.
Okay, okay. Hello, Anand. I think you are Anand, na?
Yes, sir.
What is the problem?
It is not showing.
Somewhere you are finding how to share the PPT.
I am selecting window, but what's
Share option will be there somewhere, I think.
You can email to us.
okay, sir.
If you think you can email us.
Mail on paper. Sir, paper mail.
PPT is there with you.
आप मेल कीजिए.
Okay, sir.
मेल कीजिए. जिसमें जिससे आपका लिंक दिया है उसी email में
Okay.
You mailed your PPT. Hello.
Yes, sir. Not able to do this, sir.
Please mail your PPT. Hello, Anand.
Yes, sir, I am.
Please mail your PPT to the email ID given so that we can access that. हेलो आनंद मेल किया?
शेयर नहीं हो पा रहा है मेरे।
आपको शेयर करने की जरूरत नहीं है, आप
मेल किया? मेल किया?
आप मेल कीजिए ना।
सर मैं मेल में पूरी नहीं हो सकती।
मेल कर दो तो हो जाएगा।
ओके सर, 1 मिनट।
Okay, Anand, we have your slide.
Should I start, sir?
Wait a minute. Now you are presenting.
Okay, sir. So may I start to?
Yeah, you start.
You should start.
Good evening, everyone. I am Bharti Anand, research scholar under the guidance of Dr. Subhani Pala, Faculty of Yogic Sciences, going to present a paper on exploring recent advancement in the utilization of plants for nutrition, medicine, and cultural heritage among indigenous tribes of Jharkhand. Introduction. This research probes into how indigenous tribes in Jharkhand, India use plant for nutrition, medicine, and cultural practice. These tribes have unique knowledge passed down through generations about the local flora and their diverse applications. Plants play a central role in the rituals, ceremonies, and daily lives of these communities, shaping their identity and connection to their environment. Preserving and understanding these cultural practices is vital for the sustainable development of these communities and the conservation of biodiversity. In recent times, there has been an increased interest in understanding and documenting these traditional practices. Our study aims to bridge the knowledge gap between these age-old practices and contemporary scientific understanding, exploring the potential pharmaceutical benefits of these plants. Methodology. Hello, survey. We conduct extensive field survey within indigenous communities in Jharkhand knowledge regarding plant utilization, engage with local experts and community members through interviews and participation efforts to compile a comprehensive list of plants used for nutrition, medicine and cultural practice. Second, cultural heritage documentation, engage in ethnographic research, document the cultural significance of plants within indigenous tribes, observe and document ritual, ceremony and daily practices involving plants, interview community members to gather insight into the symbolic and cultural importance of specific plant. Result and discussion. We discussed the implication for community health, recognizing the importance of plant-based nutrition in sustaining the well-being of indigenous tribes. To provide insights into the cultural significance of plants, highlighting their role in rituals, ceremony and daily practices. We discussed the implication for cultural preservation and environmental harmony, emphasizing the importance of integrating traditional wisdom with contemporary approaches to explore the interconnectedness of nutritional, medicinal and cultural aspects, emphasizing the holistic relationship between indigenous community and plants. Significance of this cultural preservation. This research is crucial for preserving the rich cultural heritage of indigenous tribes in Assam, conservation and biodiversity. The research shed light on the significance of local plant species, emphasizing their role in the daily lives of indigenous tribes. This information is critical for biodiversity conservation efforts as it highlights the importance of preserving not just the plant themselves, but also the intricate relationship between community and their natural environment. Limitation potential. Sampling constraints. Due to practical constraints, the research might not capture the diversity of practice across all tribes in Chile, potentially leading to generalization that may not apply universally. Conclusion. This research has uncovered valuable insight into the utilization of plants for nutrition, medicine, and cultural heritage among the indigenous tribes of Assam. Furthermore, the documentation of cultural practice involving plants provide a deeper understanding of the intimate relationship between indigenous tribes and their environment. Preserving these cultural connections is not only crucial for the communities themselves, but also contribute to broader effort in biodiversity conservation and sustainable development. In conclusion, this research laid a foundation for future studies, fostering a holistic approach to integration and traditional wisdom and modern understandings. The insight gained have practical implications for community well-being, cultural preservation, and sustainable development. Here are some references. Thank you.
Hello, Miss Anand.
Yes, sir.
How you bridge that gap that you have said, or earlier methods and the new methods?
Excuse me, sir. Can you repeat?
How you have your work is completed or it is still left?
My
Yes.
I am not getting your point, sir.
And I am asking your work is completed, research work is over or it is still?
Yes. My research is completed, sir.
Okay.
I have collected the data from the village that is Karra and Murma.
And your work is very relevant to the especially Jharkhand region. So I wanted to ask one thing. What are your information to the general people so that the people can get the idea from your work?
Yes, sir. There are many types of plants and herbs that is used by the tribes, which is very healthy according to the tribes. They used Kamben saag, that is Brahmi, Chakro saag, and there are many more, which is healthy and nutritive and very